All right. So I think what I like better is a quiz. Next Monday. Become a Y. On chapter 8. On all the conference intervals. I like having them all for you to have to choose from.
So just chapter 8 on the quiz on Monday?
Yeah, we haven't even started chapter 9 yet.
Yeah, I thought we were going to start that today. That's why.
Oh yeah, today, yeah. I never quiz you on something
From the previous class.
the next class after we first talk about it. Yeah. I know. It's too nice.
You are the best.
So today we're starting chapter 9?
That's the bar. That's awesome. Huh?
Today we're starting chapter 9?
Yes. Starting chapter 9 today. So again, just before we go any further, anybody else still need a copy of that? It has the large chart of data on one side. Anybody else need that copy? We're going to do the back side today.
I'm gonna go.
Okay. So me. Any questions from homework stuff? Chapter 8. Homework stuff, yes.
I have a question for section 8.1, number 98.
Yeah.
For part A.
Okay. I'm ready for the question.
So what does the SI stand for?
Oh, okay. So they kind of like to show you kind of like the way the calculator does. You got this guy here, which on the calculator again, the calculator shows sigma x guy there, x bar. Doesn't it, when you do this, when you do one var stats, doesn't it have sigma x? That's just meaning. That means that it's the standard deviation for individual values. Because the x represents every individual value. If I take a sample, what will that become? That'll become this guy, right? Which is this guy divided by square root of it. So Sx just means it's the standard deviation that they got from A. Versus this is the standard deviation of a population. This is standard deviation of a sample. I like it. All right. Really old stuff, right? Stuff we should know. Yes? But I don't know if you had more to that.
Oh, when it asks for which distribution you should use, is it the same one that we've been doing in that section?
How do you mean same one?
On the previous questions, I think some of the answers were like the mean of x and the standard deviation divided by the square root of n.
Oh, so the choices for distribution to use is really the z or the t,
Okay.
to be honest. They both require a normal distribution, but it's all about which one of those. Now, please, if I don't know this, and I only know this, I have to use what? T-scores, because that's what they were invented for, right? If I know both of these things, no. What am I going to use?
Z-score.
Hell is shit, yeah. All right, so every time, so if I go into a problem and I know this going into a problem, and when I take a sample, what can I calculate from a sample? So I go into a problem knowing this. This is known. I'm going to freaking use z-scores as long as it's normal, right? So I take a sample size big enough, n equal 4,000, right? Can't I calculate an x bar? I probably need to. Can't I calculate an s? Of course I can. Would I use this? Why the hell would I when I know this? I can always calculate s from any sample I take. So when do I have to use a t-score? When that's the only thing I know. That's the only standard deviation I have. I have to use an estimate for this. If I know this, I'm going to use z-scores as long as it's normal. Z-scores are the better thing. T-scores cover us for not knowing this. So if I know this, I'm going to use freaking z-scores. Kick ass. So yeah, I love that problem because it gives you both. And then you guys have to realize, I'm not going to use S. If I know sigma, I'm not going to freaking use S, right? So if I knew the average age of all students at Grossmont was 26, and somebody took a sample of 30 students and found an X bar of 20, am I going to report the 20? Shit, no, I'm going to talk about the known. So I'm going to always use the known about the population stuff. That's the most certain thing. S is always going to be an approximation because it's just coming from a sample, not everybody. Cool. So you only have to use a t-score if this is the only standard deviation you know. It's an estimate for this guy. If I know this guy, I don't need an estimate. I know him. Does that make sense? Anytime I take a sample, I can calculate this. Does that mean I have to use the t-score just because I happen to calculate S? No. I just calculate and go, that's nice, and erase it and forget about it. Okay, I like it. I like it. Who did I cut off? So, yes. You got it? Okay, I like it. Your question sounded like the beginning of hers, so I was like, maybe it's the same one. Anything else from homework stuff?
Yeah, number 1 or 2. It's asking for like the point.
Oh, yeah, good. I like this. Good. Hey, Jack.
The point estimate, I think that's what it's asking.
So, what's always in the middle of a confidence interval? Somebody give me the formula for any of the confidence intervals. I don't care which one. Give me a formula for a confidence interval.
Plus minus the z-score
Sure.
times the standard deviation divided by the rest.
I like it. And don't forget, what's the other X bar one real quick? It would have a what here? Because it has a what here? And you can have this on your formula sheet. So my God, if I ask you, or if there's a situation, when to use T when you only know S. I mean, look, it's in the formula. Yeah, I love that shit. Right? Second, sorry?
Do you get the formulas or do you put them on our quiz?
On a quiz, I'll put the formulas on it. Yeah. For a test, we're going to talk about making your own. Yeah. Okay. So, looking at this one up here. You guys see what is in the middle of any confidence interval you make? No. Not what's in the middle of the equation. How do you make a confidence interval? You take the mean and you add, and then you subtract the same exact amount. So what's going to be right in the middle of any confidence interval you make, or it's already been made? The mean. Doesn't that make sense? Aren't you going to start at the mean and go up this much and down this much? So isn't that mean going to always be in the middle? So if this was 7 and this was 9, what's the mean? 8. Right in the middle of 7 and 9. Right? What's the error? Which part of this equation is the error? Error. Yes, this guy is the error. Why does it make sense that's the error? Because that's this, give or take this. Give or take this. Doesn't that mean give or take 3 hours? We'll be there, give or take an hour. That's how much I think I'm off by. That's the error that I'm allowing myself. That's why we call this the error. Because sometimes math people like to use words that make sense. So this is the error. Can somebody tell me what the error is for this situation? Now we know the X bar is 8.
It's 1.
The error is 1. How do I know that? Because I added 1, I subtracted 1. Now, let's make this a little harder. What if this was 1.59 and this was 4.78? What's the mean? How do you do that? The mean is still going to be in the middle. And how do you find the middle of any two numbers? Add them together, divide by 2. Because you average them to find the middle of them, right? So it'll be this plus this divided by 2. And what's the error going to be? It's going to be how far that is away from either side. Some of you guys might realize that you can do, this is 2 divided by 2 is 1. That's the error. So you could do the difference here divided by 2. That's the error also. There's multiple ways to do this. This is really just a problem in, do you know how to mess with numbers? Really. That's all this is. That's it. You've got to know that that's going to be in the middle. And then you can just play with the numbers. I like it. So that's that problem number 102. Thank you. Anything else from homework stuff? She'll be happy she showed up today. She's helping you out on problems that I feel like maybe you haven't done yet. Okay. Nothing else from homework? All right. So let's get into some different stuff. Yes. Here, you guys, everybody take out a sheet of paper real quick.
Take out?
Yep, take out a sheet of paper.
Don't be a quiz.
It's not a pop quiz. I hate pop quizzes, so just calm yourself. Calm yourself down. Now, don't let me see. Write down a number between 1 and 10.
Big or small? Big.
What do you mean, big or small?
Big.
Oh, I see what you mean, so that I can see it or not? It doesn't matter. You can write it real tiny. Just write it down for yourself. This is not the same thing as the birthday thing. That's what you're thinking about, but it's just write down a number. Because it's too late. I already said 1 to 10. That's why.
You want it big?
It doesn't have to be, but you can make it big if you want to. When you said big, I thought like 9.9. No. Oh, you mean big or small? So all right. We're getting into this chapter about making claims and testing them. So I am psychic, which is really helpful.
You're psychic.
Yeah. And I know that the average number that you guys wrote down is 6.35. I already know how to calculate it. That's my claim. You guys with me? This is my claim. I'm obviously not psychic. That would be really freaking awesome. That would help me out a lot. But, so my claim that I've made is that the average number, if I averaged all the numbers you wrote down, including the people that wrote something less than 1 or bigger than 10, just to be that way, the average would come out to be 6.35. All right, now how would you test that? You see your own number, right? You see your own number, but is that good enough to test my claim? No. What else? What would you do to start to test my claim? Huh? Yeah, you could find everyone else's, but let's just say that you're really lazy, or you're glued to your seat, or a combination of those two. You got a little bit of glue and you're lazy, so you don't want to lift yourself up. What could you do maybe right now? You could talk to people around you. So the whole idea is one measurement isn't good enough to test a claim, obviously, right? If somebody says, I'm a really good basketball player, and they take a shot and they miss it, are you going to go, well, that is evidence that you don't know? Or somebody's like, I'm really good, and they make a shot. Is that evidence that they're really good? No, that could have been the first shot they ever made, and they just keep a straight face as well. I never heard that sound, ball going through the net. You guys kind of with me? You don't know. There's no way to tell based off of one shot, right? Especially if you only see it go in or not into the net. You got to take a few. You got to let them show you. Do you know how to shoot the ball? Do you know, and so forth? Are you guys with me? So you can't just look at your one number you've written. You need to look at a few, at least a sample to check. So I'm going to take a sample of people. I'm going to do a stratified sample. Just make it. I'm going to take one person from every row. So let's see, Tim. What number did you write down? 3. Jackie, what number did you write down? 8. Let me see. Stefan. 10. Pretend you're on this row. Paige. 7. Whoa, yeah, here comes 7. Craig. 8. Let me see. Carmen.
2.7.
I love it. Kicks ass. 8. All right. Somebody help me out. What's the average of those? That's a 7. That's an 8. That's a 2.7. 16. 23. 35.7. 46.7. This is 1, 2, 3, 4, 5, 6, 7. Yeah, it'll get you. 6.7. 6, 7, 6.67?
Yes, 6.67.
All right, 6.67. So the mean of this little sample we took, 6.67. All right, now watch. This is really getting neat. I didn't know this would happen. This is kind of kick-ass.
Oh, fuck. It's so close.
Ooh, you said fuck. What, is that evidence that I'm wrong?
Yeah.
How big of a sample is this?
There's only 6.
It's only 6. To be honest, aren't any of you kind of surprised, as surprised as I am, that it got so close? I think it's 6, right? Is it 7 or 6?
7.
I forgot. 7. And even though a decent number of people decided they don't need to come because they're that good, there's still a lot more than 7 people in here, right?
Right.
You guys with me? So is that a very large sample?
No.
But it was randomly chosen, right? I took one person from every row. You guys kind of with me? So it should be a decent representation. So the fact that this guy is so close to this, are these very far apart? What would have been here to convince you that I'm wrong, that it isn't this? Okay, now you're starting to think about it has to be very far away. And we know what measures distance in statistics. What measures distance? It uses standard deviation to measure distance. What measures distance? Z-scores. So standard deviation is what I measure in. Z-score is the measurement we take. So Z-score tells me how far apart things are. I'm trying to lay the foundation. So there's a claim somebody's going to make. I can raise your SAT score by 100 points if you take my class or whatever, right? And then we can test it by taking a sample. But we have to know, what are we looking for? The fact that this isn't equal to this is not good enough evidence that I'm wrong. In fact, it's interesting that it's so close, which is surprising to me, but oh well. Well, I just said 6.35 because most people say 7 when I say pick a number, 1 to 10. Most people say 7. I picked something that was close to it. And it came out to be a decent guess, right? So far. How could I improve my check of my claim? I could take a larger sample, right? I can include more data in my sample. So if there's a claim that's being made, so if somebody says, oh yeah, I can make 80% of my free throws, and they take 2 shots and they miss both, is that enough evidence that they can't make 80% of the free throws? No, you got to let them take many more, right? Maybe they'll make every other one out of 10, and then that's exactly 80%. Do you guys kind of follow me here? So there's a whole idea about 2 things going on. The larger the sample, the more sure we are about what we see. And also now we're getting to the point where we're able to check a claim. So now watch. What does a z-score normally measure distance from? The mean. Is this the real mean? Necessarily. It could be, but I would be really, in fact, part of me wants to find out, but we're not going to do it. Wants to get all the numbers. Huh? You guys turn your papers in at the end. Or you don't trust me. I don't blame you if you don't trust me. I'm like, I was exactly right. I don't know. No. All right. So I want to measure distance from my claim. I want you to see. I say I think the average is 6.35. And then you go, oh yeah, assuming you're right. Let's see what happens if I take a sample, right? If this would have been 9, you would have went, well, assuming you're right, look what I just did. I got 9 out of a sample. You're most likely wrong. Does that make sense?
Yes.
So assuming I'm right. So what that means, when I say assuming I'm right, you're going to assume this is the mean. We're assuming that 6.35 is the mean. And then I'm trying to see, there's going to be something that's far enough away. There's going to be, what's far enough away? Now, normally, before now, it's been 2 standard deviations is where it starts to be unusual. But like I continuously say about the nuclear power plant, whatever, I want to be able to adjust my definition of what unusual is. So the problem is going to define for me how far away is far away enough. So 6.67 might be in here. So that's not enough evidence that I'm wrong. Because if this is the real mean, where should any sample show up? Close. Any sample should be close if this is the real mean. So what if we took a sample and I got out here? Is that where it should be? So if this is the middle, it should show up on here. Let's say I get one out here. Let's go further. Let's say that it's 3.15 z-score for the sample I take. It's so far. Would you guys say that's far away? In fact, what's the probability that it's at least this far away? That it's here? What's that probability? You might need a z-score chart. It's like 0.000 something. I don't know. The day that somebody laminates one of these is going to just cry. Oh my gosh, no, just being weird. 3.15. What do you guys get when you look that up? 9992. So then what's the probability it's this or more, that it's at least this far away? 0.0008. So now I really want to make sure. Listen, we're just going over the concepts. It's going to be a very kind of defined process to do this. When I was taught, it was 8 steps. I've made it 5 steps. You're welcome. The probability, if this is the real mean, so I'm assuming it is, the probability that we would get a sample this freaking far away is 0.08%. So either this is the real middle and I just happen to do something that crazy, or what makes more sense? That I'm wrong. That the real mean is probably what? The real mean is probably bigger than this. The picture probably looks more like this. And then this wouldn't be that far away. It wouldn't be that z-score. If the middle was here, that wouldn't be that far away from it. So I assume that the claim is right. It's a very interesting proof method. Assuming you're right, look what we just did. Right?
It looks like you just picked half.
Say again?
It looks like you just picked half and be like, okay, maybe people will go less. Or
Well, again, most people pick 7. In fact, there were a couple 7s. Well, there was one 7.
Because half the
Most people pick 7, so I just picked an average that was a little less than 7. That's all I did. Yeah, and I was kind of surprised it came out so close. I was kind of hoping it would be far away, but this is kind of cool it came out so close. This is not good enough evidence, even though it doesn't equal this. It's just from a sample. So for a sample to show evidence, not only does it have to be different from the claim, but it has to be different enough. It's got to be so freaking far away. It's got to be way the shit out here to go, oh man, I'm probably wrong. The mean's probably up here somewhere. Maybe. Now, we're going to go over this idea a few times. We are. The thing that's different here, the reason that this is better than a confidence interval, is a confidence interval is built around an X bar. This is built around, assuming this is the real mean, this is built around a normal distribution. This is why this is the accepted way to test a claim. Okay. Let's do this. Let me ask you this. This was my claim, so how do I write that? Aw, goodbye, data. How do I write that in symbols? I think I had it underneath here. So this would be the mu is 6.35. That would be my claim. Now you guys should have appropriately felt I was full of shit. So what would your claim have been? That the mean was... No, you don't have an alternate claim. How do you feel about what I'm saying? You think it's wrong. So you think the mean is not equal to 6.35. Right? That's the other. So there's always 2 sides to something, right? We call the one with an equal sign, we call that, I love this, we call it the null hypothesis. This is the one that I cannot prove. can I use a sample to prove that the mean number was something? Does this prove, does the 6.67 I got prove that the average for everybody was 6.67? No. So a sample can never prove an equals. But a sample can show evidence for a not equal to, a less than, a greater than. It can show evidence for that. So if I think the average gas price right now is $2.50 because I haven't bought gas in forever. I know it's not, but let's just say I do. You'll look at me like, no. And you're going to take a sample of gas stations and get something so freaking bigger than this. So a sample can show evidence that the real average is bigger or less. It just can't prove that it's equal to something. So that's the one, we call this the null hypothesis. This is sort of like the stick in the mud, kind of like it's the middle. Say again?
It's an H and O.
Yeah, it's what I affectionately call the hoe. Okay? You're going to deal with that or not? And then this one, some books have this as an HA for alternate. I think this one has H1. So the hoes and the highs is what we're going to be talking about. Yeah, so the alternate one is just the opposite of this.
It is a hypothesis.
Say again, yes. So these are two hypotheses. These are feelings we have about the outcomes of analysis of data before we've actually done it. Right? So it could be based on theory, it could be based on feelings, it could be based on whatever. Okay. So watch. If my claim was that the mean is less than 4.2, let me see if you guys were paying attention a second ago. Which one of these would that be? Which one would that go into?
The top.
The hoe is the one that always has to have an equal sign. Does that have an equal sign?
No.
No. So that's going to be the high.
Oh.
And what's the opposite of this? What's the opposite of mu less than that?
More than.
Almost. Greater than or?
Equal to.
Equal to. See how the hoe has the equal to sign? I like it. Okay, maybe. So we're identifying there will be a claim that somebody makes. Haven't you guys heard of people making claims like this egg cooker will cook your eggs a minute faster, or some claim like that? Right? It doesn't even have to be numerical. This oven will make better tasting steaks. I guarantee it. Whatever. Right? So that's a claim that's being made. We can test that claim. So there's a claim that's made. There must be an opposite statement. So these guys are always opposite of each other. All right. I like it. So let's do this. It's a little easier to go through these steps if we have an example to kind of look at. So does everybody again, let me try it one more time. Everybody have one of these? It's got all the data on the one side. And the other side is what we're going to talk about right now. So get that out if you got it. If you need it, I got some more copies. You will cooperate.